Hi everyone, I'm Doug Black, Editor-in-Chief of Inside HPC, and today at the SC22 conference in Dallas, I'm at the Altair booth with Altair and AMD to talk about their collaboration and partnership. And with me is Eric Lequiniou. He is VP of Radioss Development and Altair Solver HPC. And from AMD, I'm with Kevin Mayo. Kevin is Director of HPC Engineering. Gentlemen, welcome.
Thank you.
So why don't we start with Eric. Eric, tell us a little bit about recent developments in the collaboration with AMD.
Yeah, in fact, it's a long story of collaboration between AMD and Altair, and especially regarding the Altair solvers. Because in fact, since the EPIC first generation, we are collaborating together, okay, to improve the performance of the solvers on EPIC generation. And here we were collaborating more precisely to test the fourth generation of EPIC using Altair solvers. So using OptiStruct, the structural analysis solver, AcuSolve, the CFD solution, and also Feko for electromagnetism, and Radioss for crash and impact.
Okay. And Kevin, congratulations on the recent launch of the Genoa chip.
Thank you.
Could you give us an update on that product?
Yeah, so it was very exciting for us to do here recently. If you look at our prior generation Milan, the 7003 kind of third generation, it was taking the step towards Genoa. We've doubled in a lot of areas. We've added more cores, but in order to add 50% more cores, we doubled memory bandwidth. We have 12 channels of memory now instead of 8, which adds about 50% memory bandwidth. Moved from DDR4 to DDR5, up to 4800 on the speeds there, and so that adds another, call it 50%. So over 2x on the memory bandwidth. PCIe Gen 5 gives you an option for twice as fast PCIe performance. Our Infinity Fabric, next generation Infinity Fabric, has given about twice the performance of the prior generation as well. So all the areas that kind of feed the beast, feed the cores, have basically doubled, and then we've been able to go up 50% in cores. So where people in the HPC space, especially in the commercial side, may not have paid up to get the highest core counts. They find that sweet spot in the middle of performance per core. And so in the Milan generation versus Genoa, now I think with all those other feeds coming in faster, I think you can start looking up the stack a bit and get a bit more density, even if you weren't buying at the top of the stack in the past.
Okay, tremendous. Tell us, describe some of the benchmarks you worked on with Altair. I guess there were 4 solvers.
Yep, across the 4, worked with Eric and company and got some good, kind of their standard benchmarks really. So we didn't do anything too fancy with it, but they provide good benchmarks that are representative of real world workloads. And so when we run those, we feel good that the performance uplift that we show is something that customers will realize when they run their data center. So they had nothing too fancy there, just kind of the standard representative benchmarks.
Okay, so Eric, over to you. Yeah, what were some of the benefits that you realized from those benchmarks?
Yeah, so again, I want to underline the fact that here we are talking about a factor 2 and more. So it's really impressive. Okay, so it's not a moderate improvement, it's a huge improvement. And in fact, for us and for our customers, this means that they can run more complex simulation, more detailed model, more predictive model. If you think about electric vehicle, you need to integrate a battery pack into the simulation of the car crash. And only the battery pack can represent 30% more elements to compute. And also, to be more predictable, it's really important to have bigger model, more accurate, and things like that. So really, with this performance, you can stay in one night simulation for advanced simulation like that. Or for, let's say, more moderate models, this means that you can run more simulation, so you can do optimization of your product, then have more insight, so then make better product helped by simulation. And this is really the purpose of Altair, to deliver all the tools for our customers to take better decisions, relying on simulation, on HPC, cloud, on, workload management, and also on AI and machine learning, things like that, all together to accelerate the innovation.
Okay, great. Now, Open Radioss was announced in September. Tell us a little bit about that new product.
That's a great question, yeah. In fact, the launch was an enormous success, okay? And since then, the community is really growing very fast. We see amazing collaboration on many different domains. We will have the first workshop of Radioss users next week in France. So people will see how the contribution and the people are enthusiastic to have a finite element code available to do their research. Okay, so this is really nice. This is a game changer for the CIE community. And really it's an addition. We use Open Radioss as a upstream development to accelerate innovation pace. And at the same time, we maintain a very robust, very commercial version of Altair Radioss, the commercial version that exists since 30 years and more. And the way is to, let's say, use the both to bridge the gap between innovation and commercial software with all the robustness, the performance that our customers like, with all the support, the documentation of released version with the commercial version. So this is, in few words, the idea behind the scene. And I encourage the audience to go to look at openradioss.org to learn more about the project. And of course, to go to GitHub, Open Radioss, to download the software and to begin to innovate together. It's a new way to do a software, let's say.
Okay.
Really a game changer.
We're excited about it as well.
Very good.
And we are really happy to have
Yeah.
AMD coming as early contributor. And already you have Open ACC into the compiler with Open Radio. So it's really nice. I mean,
Yeah, great step for innovation in general.
Yeah.
Great. Well, we've been with Altair and AMD, Eric Lequiniou of Altair, Kevin Mayo of AMD. Gentlemen, thanks so much.
All right, thank you very much.
Thank you, Doug.